Hello everyone, welcome to Ocean Cafe. In this lesson, I will be going through some of the formulas that you would need in order to find arclength, sector, and segment. If you have not watched the short videos that I've created, you can visit the two videos, the short videos, right? You may want to check it out, the link below the description. So as we begin, there are some terms that you need to be very familiar with. So as you can see from here, which is arc length, which is minor arc, which is major arc. So for major arc, you will need to know the reflex angle. And in this diagram, what you see are the two different sectors. So one is minor sector and major sector. And this is also something we are familiar with a chord. So a chord that is divide a circle into minor segment and major segment. Now let's recall some of the formulas that we have learned before. So we talk about minor arc, right? The minor arc length. So what is the fraction of this minor arc compared to the entire circle? So if we talk about fraction, so we can actually look at the angle, so which is the theta, and over the entire circle, because angle at the point is 360 degrees. Now let's take a look at the formula for circumference as well. So we know that circumference is 2 pi r, area of a circle is pi r squared. So if we are going to convert and to find in terms of arc length, then what we have is arc length is a fraction of a circle. So therefore we put them together, and hence I have theta over 360 times 2 pi r. And similarly, if I want to find area of sector, then it will be a fraction of the entire area of a circle. So it's theta over 360 times pi r squared. So over here, we are going to explore the formulas to find area of segment. So first, let's recall area of a triangle, which we already know is half AB sine C, right? So which means the A and B here, simply the radius, so half times R times sine theta. So to find area of the segment, so what we have will be area of the sector, which is what we explored earlier on. We can see in the previous slide, so area of the sector, which is this one here, and then I minus off area of the triangle. Yeah, so I minus off this area of the triangle, and hence I will be able to find area of the segment. Let's take a look at these two circles. All right, what is something different that you notice from these two diagrams? So you notice that the angle look different. Yeah, so we have 1.05 instead of usually see 60 degrees or 65 degrees. So over here the numbers are smaller, 1.05, or sometimes, all right, you could see the angle given to you is in terms of pi. So exactly why is that so? So in this case, 1.05 and pi, these are angles that are in radian mode. So I have also a short video on how to do conversion of the radian mode, all right, to degree mode. So you can check out that video over there. So what if the angle given is in radian mode? Yeah, we already know that in degree mode, all right, we have already worked out this formula, which is theta over 360 times 2 pi r, if we want to find arc length. Now, if you observe, right, 2 pi, it is also equals to 360 degrees. So which means if I want to find arc length in radian mode, what I can simply, all right, do is can equivalent to cancel away the 360 and the 2 pi, and hence this is how we derive the formula, all right, in radian mode to find arc length. So on the similar note, all right, I can also find area of the sector, all right, given the radian mode. So we recall in degree mode, yeah, the formula that we have earlier is theta over 360 times pi r squared. So in this case, because it is a pi here, so 360 is the same as 2 times 180 degrees. So which means if I put these two together, I have r squared theta. So this pi over 360, right, it is actually equivalent to half. So therefore, this is how we derive the formula to find area of sector in degree mode. Yeah. So how about area of segment? So area of segment, we already know the formula that we derived earlier on, which is area of the sector minus of area of the triangle. So in this case, this can be easily done. Yeah, so what we need to do is just to make sure that the data is in radian mode. Now with this, let's do some simple applications, all right, to see how we can apply the formula. So take a look at this diagram. So one consideration that we will need to have and bear in mind is to ask ourselves which formula should I use. So in this case, what we see here is that the angle that is given, it is in degree mode. So hence, if I want to find the minor arc length, which is here, so I will simply just take 75 degrees over 360 times 2 pi r. So if I would like to find the major arc length, which is the bigger arc, so in this case, what I will need to consider will be, I will need to have the reflex angle. So therefore, put them together to find the reflex angle. I just simply take 360 minus of 75 over 360 times 2 pi r. Let's take a look at the next example over here. So in this case, what we will see, all right, is that the angle given, it is in radian mode. Alright, so in order to find the parameter of the shaded area, so what we will need is to find arc length. Yeah, so the parameter that we are talking about here, right, it will be here. So this length here, which we can easily find, which is given from the same side here, which is equals to 6. And then I also need to find the smaller arc length here, which is equals to r theta. And then lastly, we will need to find the bigger arc length ABC. So by putting all this together, we can easily find the area. So what we do know is that this length here, it is equals to 2 cm. Yeah, so if we want to find this small arc length here, the smaller arc length here, so radius is equals to 2, and then the angle it is given, which is also 2 radian. Yeah, and then when we want to find the bigger arc length ABC, so over here the radius now it is equals to 8 cm. So I simply take r as 8, and then the theta is 2. So putting this together, so I'm able to find the bigger arc length plus this smaller arc length, and then I just simply add the 2 times of the 6 cm. So with this, we can easily find the perimeter of the shaded area. Okay, now let's take a look at the next example. So in this case, this diagram that we see here is slightly more complicated than the other two that we have seen earlier on. So for practice purposes, all right, we shall apply the formula in radian mode. All right. So over here, what you can observe is that we see a regular pentagon. So for this pentagon, all right, I can divide it into 5 equal parts. So with these 5 equal parts, what we know is that for one complete cycle, it is equals to 2 pi radian. So what I'm keen here is I am going to find out what is one angle here. So let's call this theta. So to find this theta, because one cycle is 2 pi, so therefore to work out one angle, so it's simply 2 pi over 5. So in order for us to find the area of the segment, the shaded area, right? What we need to do is we just simply need to work out what is area of one segment. So to do this, we apply the formula that we have learned earlier on, right, which is half r squared theta minus half r squared sine theta. So in this case, the sector that we are referring to, it will be this area, this sector here. So let's sub in the value. So we have radius as 14, and then the theta as 2 pi over 5, and then similarly I apply into half r squared sine theta. So just to take note that when you do this, right, the angle here has to be in radian mode. Yeah, so now with this, right, I am able to find what is area of one segment. So total, we will see that there are 5 segments. So we do a count 1, 2, 3, 4, 5. So to find the total area of these 5 segments, all I need to do is I just take 5 times of the value that I've gotten from the earlier part. So with this, right, this is easily done. Okay, we move on to the last example for this lesson here. So what you see here is we want to find the shaded area. So you will see a square, right? ABCD is a square. This is a diagram whereby we have seen it before from PSLE exam. Yeah, so we have this. So if we take a good look at the diagram, right? So what you will see is actually we see a quadrant. Yeah, so since this is a quadrant, I will note that the angle at the corner here, it has to be 90 degrees. Now I'm going to add just one more line, right, to the diagram. So what I have here is I add the line, right, to join from B to D. So if I add one line, right, so what you see here is you are able to see that is actually a segment. Right, we see this segment here. So we're area of this segment. So then if we take a look, I have another quadrant here. So in a way, if I want to find the shaded area, all I need to do is I just simply need to work out area of one segment, and then total there are two, which is here 1 and 2. So total there are two segments here. So to do this, all I need to do is find out 1 and then I just multiply by 2. So putting all this info together, I can just find the area. So in this case, because I know that it is a quadrant, yeah, a quadrant. So therefore, to find the area is simply 1/4 times pi r squared. So you notice in this case, the question never state whether we use radian mode or degree mode. Yeah, so therefore, what we can do is I can simply just use 1/4 pi r squared. Right, simply is in the degree mode. So I can find area of the sector, and then to find area of the triangle, yeah, so it's simply half times base times height, because since ABCD is a square, so both same length. So with this, to find the shaded area, all I need to do is it is 2 times of area of the sector minus of area of the triangle. So with this, we are done. So I hope you find this this lesson useful. This is just a very basic one, right, to demonstrate to you how the formula come about and how we derive the formulas to find arc length and area of sector and segment, right, in radian mode. And the examples that I use here, these are actually not very difficult one. So do go ahead and give it a try. All right, it is actually not tough. Right, so with this, thank you for watching. I see you in the next video. Bye.